Hello guys, let us find or evaluate the composite function. Composite function, we have f of g of x, f of g of x. We should find f of g of x and find the domain, right? We're given, we have f and we have something like dot that has a hole. This is equivalent to, if you're given something like this, there's some small thing like 0 like this. But if you have something like this, let's say it's a shaded dot, and this means what? Multiplication. This is equivalent to f into g of x, right? This is equivalent, but this, it is a multiplication of the two graph. That means this is the multiplication of f of x multiplied by g of x. That is the difference between those two, right? So we have to evaluate, we have to find this. We're given, we'll start by these two, right? Let us find that. But we have to know, if you're given this thing, f g of x, right? This is an input, this is an output, right? It's an input, that is an output, right? Input and output. So this is an input. What is inside? It means that there's it's an input, it's a fraction inside the fraction. So right, fraction inside the fraction. So this will be equal to, here we have f of g. You put f of g here, you'll have f of x, right? But you replace by f of g. Here it's f of g, right? This will be x squared minus 3, right? Right, but what about this f of g? F of g is this one here. This is the same like as if you have f of minus 2x, right? And then you're given the equation like this. Let's say you're given an equation like that. You're going to replace, you will take this minus 2 inside here, we're going to have negative 2, right? Minus 6, minus 4, you'll have this thing, right? So we'll apply the same rule what we know there. If you apply the same rule, we know that this will be equal to, where you see x, you replace, where you see x, you replace with this, you take this there, that will be 3, right? Then you substitute, when you see x, you put x squared minus 3, right? Then you have that minus 4, right? You have this, then this, you apply your math, right? This will be equal to, will be 3x squared minus 9 minus 4. This will be equal to 3x squared minus 18, right? This is what it's f g of x. It's a composite function. This is a composite function, right? This you'll have, this is a composite function. So what about the domain? When you have a polynomial, you see, this is a polynomial, we're focusing on g of x. We have a polynomial. That means there's no restriction. That means there the domain will be, there is no restriction, will be from negative infinity into positive infinity. Remember, this domain here is an element, x is an element of real numbers, right? There's no restriction. X is an element of real numbers. So we're given number 1. We're given f of x is equal to 4 over x plus 2, or g of x is equal to 1 over x. Right. If you're given a rational fraction, when you have given a fractions and you've given we're given radical or square roots, there will be restrictions. So we have to find restrictions first. So restrictions, you must know, if you have a fraction like this, x here, x must not equal to 0. Remember, if this is 1 over 0, this will be undefined. So x cannot equal to 0, right? Then we want to find the domain of the, when we find the domain of this thing, we don't focus, we'll focus on the input, not on the output. We'll focus on the input, not on the output. Remember, right? Because we have f g of x is equal to, right? Here we'll replace this, right? Isn't it? We'll have f, we replace that because this is g of x, here's g of x. Replace that here, we'll have 1 over x, right? We've replaced that. Now, since you have f here, we'll take this and substitute there. That will be equal to 4 over, when you substitute, there will be 1 over x, right, plus 2. Remember, this is our input. This is our input, which is g of x. Here is g of x. It's our input. That one will be our input. So we'll focus on g of x, right? We'll focus on the input. So multiply by x on top and bottom, multiply by x, that this will give you, will be 4x over x, and x here will cancel, we'll left with 1, substitute, multiply, there will be 2x, right? Now what did you get? You got a fraction. If you have a fraction, remember this is our composition, then it's when you have to find what? The restriction. Let us find the restrictions. The restrictions here, it's a fraction, right? 1 plus 2x must not equal to 0. That is our restriction. 1 plus 2x must not equal to 0. Let me write there. Here, restrictions, this 1 plus 2x must not equal to 0. Then let's solve for x. When you solve for x, it will be 2x. Transpose to that side will be minus 1. Divide by 2 both sides. X will be equal to minus 1 over 2. Right. We have these values. We have our restriction is this and this. We have 2 restrictions, right? So since you have these two restrictions, you can use to determine the domain, you can use a number line. It's up to you. You can use a number line. You can say, you can use a number line here. Apply. You can use a number line like this, right? So here you can put 0. Here there is 0, right? In our number line, from 0. Let me just write it here. Here we'll have what? Here we'll have 0. Then on this side, negative is in this side. Here I can put -1/2. -1/2. Right. So x must not equal to 0. Here you'll use a circle. You don't shade, you just use an open circle, right? X must not equal to 0 restriction. You must not use the open circle, but if you include it, you'll use the shaded thought. Use an open thought, then right, these are the restrictions only. That means x can be any number between here, can be any number between here, also can be any number until when you go to that direction. There is no restriction here. S can be number until here, until there. When you go to that direction, that means from this direction is negative infinity, in that direction is positive infinity, right? So our domain will be from, you take from the left, you go to right. So I will say you put your parentheses, right, minus infinity, negative infinity, into -1/2, right, union from there until here. You come again, this portion, take from there until there. Now you take this until here, this portion, -1/2, -1/2 into 0 is not included. Also we'll take this will be 0. You will take this until there, we took that until there, and then we took that until there, so we took that direction. Also will be 0 until what? Positive infinity. Till positive infinity. This is our domain. This is the domain of composition, or right, function of composite function. This is that is a domain of composite function. It's a domain of composite function. Just use the input, right? This is a domain. Right, we are done with this. Let's go to that. Let's go to that. Right, that is 7 into there's no such thing here. That must be equal to what? 2/x, right? Must be equal to 2/x. It's what we have now. Number 2, we have f of x equal to 7 over x plus 2, g of x equal to 2 over x, right? So we have to determine, first we determine this. This will be called, substitute this with that. Now we know take this there, 7 over 2 over x plus 2, right? Then multiply by x here, multiply by x, then 7x into this, and this will cancel there. We'll have 2 plus 2x, right? 2 plus 2x, that is what we'll have there. 7x over 2 plus 2x, right? This is equal, this is f g of x, right? We have this, but our input here is g of x, isn't it? Then we check the restrictions there. G of x must not be equal to 0 because this is a fraction. What is the restrictions here will be 2 plus 2x, right? Must not equal to 0. Then 2x must not equal to minus 2. Divide by 2, both sides will be minus 2 divided by 2, right? Then x there must not equal to minus 1. X then must not be equal to minus 1. Fine. When you put minus 1 here, we'll have 0. Remember, yes, we'll have 0. Minus 1 will be a restriction there. Right. So we have minus 1, and then we have x, no, the 2 restrictions. Now you can, I hope now you know this, can use your number line, here, restricted here, 0 is not included. Use an open thought here, right? Minus 1 is not included. Then this x can be any number between here. Also x can be any number until go to that direction. Until that direction, x can be any number here until there. So but x is included to be -1, is restricted between these two. So here we have negative infinity, here we have positive infinity. So x, the domains will be from negative infinity. Let me write that down. D minus negative infinity into minus 1 is not included. U -1 into 0 u u bracket 0 to positive infinity. This is domains, right? That this is a domains composition function domains. Those are domains for, right? Those are domains. Now, since we got those domains, let us deal number 3. We have f of x equal to x squared plus 3 g of x equal to the square root of 4 minus x. Right, so we use that. And this is this, right? Isn't it? Then we'll have f, we replace this, here is g, which is this, will be square root of 4 minus x, right? Minus x, f of x into the square root of 4 minus is this one here. Substitute there into x, then that will be equal to square root of 4 minus x, then you square that, plus 3. Then mathematically this square and square root will cancel. We've left with 4 minus x plus 3. This will be 7 minus x, right? This is our composite function. Now the input here, that is an input, so it's f is g of x, right? Is g of x. Here we have g of x. Let's check the restriction for input g of x here. If you have a square root must not have a negative, right? A negative value there, because this will result as imaginary. So that means anything that must not be negative, that means must be greater than or equal to 0. So you take what is inside here, just come there and say 4 minus x must be what? Greater than or equal to 0, because the square root of 0 is not imaginary, is not imaginary, right? So if you punch a calculator, if you take your calculator, punch -1, get what? Error, it's undefined. So right, so we have here we'll use this, then we'll have negative x is equal to will be equal to, take that, will be -4, then divide by a negative. Remember, this is greater than or minus. When you divide by negative, you divide by -1, this will change the sign. The inequalities change the sign. This will be like this, like that. That means x must be less than 4 but equal to 4, right? We have that either x is, but this is a polynomial, there is no restriction, yeah? Since there is no restriction, we have here z, the x must be equal. That means here our domain will consider this, because there's no restriction here. Polynomial, this one is always from negative infinity up to positive infinity here, so there's no restrictions. So this will be x must be less than -4, but okay, let me use, since I've used this method of, let us just continue with the number line method. X must be less than, anything that is less than, okay, let me just put this thing here, let me put 4 there, then I make the dot here, right? 4 must be less than, that means anything that direction must be less than, okay, must be equal, this equal, then here will be, I would use a closed dot there, I will use a not an open dot because it's included, 4 is included there. Then x must be less than 4, that means we go to this direction, right? So x can be, anything can be from here and anything from the left, right? Can be anything from the left, then this is negative infinity, it can be anything here, right? That means our domain can be from negative infinity up to 4, but now we use a closed bracket because 4 is included and x is equal to 4 is included here, but cannot equal to something that side. So this is what we have there, right? So our domain there, we'll find those domains, right? Let me adjust this camera. Number 4, we have f of x must be equal to 2 over x plus 3 into g is equal to 1 over x. We use that thing as you have told us. So you see here, it's, if they give you, it can be, they can change this. Let's say maybe they say g, then they say f of x. You use the one, if it's like this, that means the input here will be this one, right? They can interchange, right? Because now we have to use that method. You have to follow that instruction there. We have to follow that instruction, g of x, right? It's equal to, also this can be written as, yeah. So here we substitute that, we have 1 over x, right? Then f 1 over x, substitute this here, then we'll have 2 over 1 over x plus 3, right? So this cannot equal to 0, so x cannot equal to 0. So since x cannot equal to 0, I will multiply by this x here on top and bottom. This will cancel. I'll have 2x into 1 plus 3x. Then here, now let us find our restrictions. We know x is restricted not to be equal to 0. Here we take what is in the denominator, 1 plus 3x. Since it's a fraction, must not be, will be restricted to be equal to 0. Then 3x will be equal to minus 1. Then x will be equal to minus 1 over 3. We divide by 3. Then we restrict this. This will be restricted. Right. X is restricted to be negative 1 over. Okay, fine. We have this. We use this is a composite function and use its input. We are done. We use its input. So you can apply your, you can use a number line if we want. Again, let us just continue this method. Right. Let me put here 0 is restricted, then we'll have dot that has an hold. We'll have 0 is restricted, we'll have dot that has an hold. Then negative in this is in this left side, right? Then let's say here I have minus 1 over 3. Then is restricted, we'll have open dot like this, but is restricted to not be equal to minus 1 over 3 and 0. So but there is no restriction for other values. That means x can be either any number from here and any number until there, till positive infinity. X can be any number till here until positive infinity, negative infinity. So that is it. Then use a number line. Then our domain, negative infinity minus 1 over 3, negative infinity until there, also goes until there, say or from here until there, minus 1 over 3, right, 0 till there, the 0 into positive infinity. That is our domain, right? So let's find the last one, number 5. Oh, this must be f of x. This is f of x. X squared plus 4 and g of x. Right. This is a polynomial, okay? Apply this, we know f of g of x, our composite function. Substitute this, then will be f, then will be 1 minus x like that. Then this there. Then if we replace that there, this is almost the same as this thing, right? They are all slightly different a bit, but just the difference is what here is 3, here is 4. Okay, then this will be equal to 1 minus x square, that is the square, plus 4 square root, and that will cancel. We'll have 1 minus x plus 4. This will be 5 minus x. This is a polynomial, is not restricted. There is no any restriction here either way. Since this is a polynomial, there is no restriction here. It's not restricted. It's either will be from negative infinity to positive infinity. There is no restriction there. The domains here are not restricted, but here we don't know. We have a radical. We're supposed not to have negative, right? So the values which are inside here, the expression here must always be greater than or equal to 0. Is it that way? Because the square root of 0 is 0. Otherwise, so yeah. Or also you check if you have something like this. If this is an even, remember 2 is an even, will be, we can, but if you have odd values like this, we know that there will be no restrictions. But if it's like this, there will be restrictions. If you have square root of 4, this is what, it's an even number. If you have here, it's an expression. We have an expression here. Here it's an expression. Here maybe we have things like let's say here 4, let's say here we have 3, so and so on. So you see 3, 4 and 3, this is an odd. Here we have even. If you have an even number there, this expression will be negative something. We have to evaluate, we have to restrict, we must find x y is greater than or than 0. We must find the expression, must find this expression y is greater than or equal to 0, but this one there will be no restrictions. We know it cannot be, expression cannot be negative if it's like that, right? So yeah, so 2, this is the same as this 2, so definitely the expression will be negative. So let us try and restrict that. There will be restriction either way. So 1 minus x must be greater than or equal to 0. Then minus x must be greater than or equal to 0. Then x you divide by negative. This will change. When you will change the direction, the inequality will change the direction when you divide by a negative value. Remember here, what I'm doing here will be minus 1. Then this will be positive 1. Will change the inequality because it's divided by minus 1, right? So we only have this restrict. That means our domain here. Okay, if you like, we can also again use the number line, but that one now. But this one is the simple one. We know we have here, let's say we have 1. We have 1. Okay, is equal here. That means I'll use a shaded dot. it's included here, but must be less than. X can be any value until there, which this is negative infinity. So is this can be any values there from negative infinity until there. That means our D can be any value from negative infinity up to exclude. You use the faces. Don't is not included. Is like this. You don't use a close bracket there. Then this is our domain there. Thank you guys for your time, and do not forget to subscribe to my YouTube channel. Thank you. See you when I post some new video there.